السلام عليكم ورحمة الله وبركاته. الحمد لله والصلاة والسلام على أشرف الأنبياء والمرسلين. أما بعد, this is the 9th lecture on the lecture series on the steady state errors. Today we will discuss the parameter sensitivity, and it means that if a parameter in the closed loop is changing, how it will affect the steady state errors. But one thing you should keep in your mind, like whenever a parameter changes inside the closed loop system, it can change the transient behavior as well as the steady state behavior of the system. So ideally the sensitivity should be close to 0, and a control engineer should be very careful when he is designing the closed loop that the sensitivity of the closed loop should be very small with respect to changing the plant or controller parameters. So we will be discussing this topic briefly, though the topic is very extensive and it needs many lectures to discuss the problem in depth, but here it is just a brief introduction to the problem. So what is the sensitivity measure? So this is a change in the system parameter, how a change in the system parameter affects the behavior of the, and when you are say behavior, this can be steady state performance and it can be a transient performance, that how they will change. It is usually desirable that a control system has a low sensitivity. In ideal case, it should be 0. So we discuss a simple example. Like suppose we have a function. This function has nothing to do with control system. This is just for the understanding the concept of the sensitivity. So here is a parameter A. Now changing the value of this parameter A, how the value of f will change. So a change in the A, how f is sensitive to a change in A. So this is the problem we will be discussing here. Like suppose you consider whenever A is equal to 100, then this function will give us f is equal to 0.091, and if A is equal to 300, f will be giving us 0.032. So there is a big difference between this value and this value. Here if we see in detail, the change in the value of f is minus 65%, while change in the value of the parameter A is 200%. So in this particular case, we can look, suppose we say what is sensitivity. So fundamentally the sensitivity we will study in detail later on, but the final equation will be somehow in this format, like the sensitivity of function of f with respect to parameter A, we can give it A upon f multiplied by df upon dA, and we will discuss that why it is equal to this. So we define that the sensitivity of a function by definition, whenever there is a small change in the parameter which tends to 0, fractional change in f due to a fractional change in p. P is the parameter. So if the parameter is changing, what will be changed in the f? So this equation we can write the fractional change. So limit delta p tends to 0, we can write it in delta f upon delta upon f and delta p upon f, so which we can write in this format. And of course, whenever limit delta p tends to 0, then this means delta f upon delta p will become the derivative of f with respect to p. So the sensitivity of the system will be p upon f dot df upon dp. So whenever we want to find out for any function the sensitivity, this is the relationship we will be using. So here we will discuss an example, and in this example we want to see that how the closed loop transfer function will be affected whenever there is a small change in parameter a. So the closed loop transfer function, of course, we can calculate. It will be T of S will be equal to K upon S square AS plus K, like this closed loop can be written like this. Then the transfer function is here, so T is here. Then by definition we know that sensitivity of the transfer function T with respect to A is equal to A, the parameter A upon T. So we will take the derivative of dt upon dA. So we write A, then we write here the transfer function, and we take the derivative of this, which will be equal to this format. If we simplify this relationship, we will get this. Now in this whole scenario, if we are looking for a large value of K, the sensitivity will be small. This means if the loop gain is very high, the transfer function T of S will be less sensitive to the change in parameter A. So in the design problem, if we want to design less sensitive system, this means that we have to choose large value of K. But again, there is a trade-off, like in the closed loop, in many situations, whenever we increase the gain K, the closed loop become either underdamped oscillatory system, and in many cases it may become unstable. So here the conclusion is, for this example, conclusion is that for large value of K, the sensitivity will be small, which is desired in the control system. So in this example, we are asked to find the sensitivity of the steady state error, and we know the steady state error to change the to changes in the K. Like if there is a change in K, how the steady state error of this closed loop will happen. And the two questions are there. One, the sensitivity because of K, and sensitivity because of the parameter A. So because this parameter or this parameter. So first important thing that we should find out the steady state error, and you know that this is the type 1 system, and in type 1 system the first thing we have to find out the velocity constant. And because we are looking for the ramp input, so ramp input will be constant, and the steady state error for the step input will be 0, and for the parabolic input it will be infinity. So here first thing that we should be finding the kV, and we know that kV is equal to limit s tends to 0 as g of s, and this will be equal to limit s tends to 0 s into k upon s plus a into s. So this s and this is s will cancel, and we will get k upon a. And now the E infinity, the steady state error, we know is equal to 1 over kV. So this will be equal to a upon k. So now fundamentally we have to find out the sensitivity of this E infinity. So the way we find the sensitivity with respect to k, so if I say that sensitivity of E infinity with respect to A, so it will be equal to A upon E infinity into D E infinity upon dA. So in this case it will be equal to A divided by A upon K, and derivative of A upon K will be definitely equal to 1 over K. So this K will cancel with this K, A will cancel with this A. So we will get the sensitivity of the steady state error with respect to parameter A is 1. This means it is a direct relationship, like whenever we will be changing A, so in the same proportion the E infinity will be changing. So changing the value of A is not going to reduce the sensitivity of E infinity, or it cannot increase it. So it will remain the same whether it is small or big, but the sensitivity of this error will be remain same. It will be not changing. Now we look for the second thing. So I will clean this. Then we can again look that E infinity we know is equal to A upon K, and again if I want to see sensitivity of E infinity with respect to K, then it will be K upon E infinity into D upon D of K E infinity. So here you will be getting K, and this is equal to K upon K. So this whole K, this will be giving a square, and here we will have D upon dt dk, and it is A into K to the power minus 1. So this will be equal to K square upon A multiplied by minus A K to the power minus 2. So if we look to this, this will be minus 1. So here the sensitivity is minus 1. This means that whenever we are increasing K, the E infinity is decreasing. But again the absolute value is 1. So this means changing the value of K or value of A will not reduce the sensitivity of the steady state error in the loop. So these two parameters cannot reduce the sensitivity of the closed loop in the sense of the steady state error. So here is the clean solution. So you can go through this again. So you will get the similar results. So increasing or decreasing the value of A because it is 1, or K will not be able to reduce the sensitivity. The negative sign over here, this shows that whenever you are going to increase K, the steady state error is decreasing. So here is an example for the student to practice, and this will give you an indication that if you understood the lecture on the sensitivity. So here you have to find out the steady state error effect on the sensitivity of the steady state error with respect to K, A and B. So do it yourself. If you are finding some difficulties in doing this problem, I think you should repeat the lecture, watch it again and read the material from the book. Until when you can solve this problem, this means you have digested the material of the lecture. So this was the last lecture in the series of the steady state errors. Thank you very much for watching the lectures and wish you best of luck. You will get for this chapter problem in the quiz 2, and also you will get problem from this section in the final exam as well. So do it carefully.